All right, everybody, thank you for coming. We will get this started in just one moment. We appreciate you joining on your lunch break. So we'll get a couple reminders, but we're letting everybody go ahead and get logged in, and we'll get started here soon. Just a reminder, if you have any questions, we do have a QA section within Zoom. You can go ahead and drop all of your questions into. We'll be monitoring that throughout the chat. You are also welcome to drop questions into the chat portion. And while we have all of our participants and attendees, all of our attendees automatically muted upon coming in, if you'd like to ask your question in person, feel free to raise your hand, and either myself or our host will be able to take you off of mute and let you speak directly to our panelists. We're really excited today because we've got a great group who are going to be going over some of the information in Roundtable. Let's give it just one more moment because I see a few more people adding, and then we'll get started. All right, looks like we've got slowed down on everybody logging in. And again, thank you so much for coming to join on your lunch break. We're really excited to round out our application modernization month with a roundtable talk of several exciting people, many of whom you have even had a chance to see speak throughout the month. If you missed any of these fantastic presentations, though, feel free to hop over to improving.com and you'll be able to find recordings of all of our previous talks. Now, I'd like to have the honor of being able to introduce Kenneth Davidson. Kenneth is going to be our host today, and we'll actually be interviewing all of our panelists. And we're really honored to have Kenneth. He is from our Ottawa office here at Improving, but is living in Montreal. And he's been an engagement manager with Improving for the past year and a half. He's experienced in service delivery and establishing strong client relationships, working across many different industries, including agriculture, legal, telecom, and other large industrial organizations. He's passionate about business transformation and technology. So Kenneth, let me turn it over to you, and we'll let you take a moment to introduce this fantastic group of speakers.
Thank you, Emily. Glad to be here. And can we go to the second slide, please? I'll start off the introduction. So we do have Marina joining us. Marina is out of the Improving Ottawa office as well, and she is one of our technical directors. She's got expertise as a solution architect, cloud computing, DevOps, and earlier this month, she presented a talk on modernizing your software landscape. We've got Michael Perry, who is a director out of the Improving Dallas office. Michael is a software mathematician. He is a Dallas-based improver for 11 years. He's an architect, developer, and trainer focused on distributed systems, and he's the author of The Art of Immutable Architecture. And then we also have from Ottawa again, Reed Spencer, the VP of Technology. Reed has been involved in a wide range of software development projects spanning over 40 years. He sets the technical direction for Improving Ottawa, assists with sales engineering, and helps Improving Ottawa on the leading, not bleeding edge. Reed loves to help customers use technology to solve business needs, has a passion for performance optimization of systems and people. We have Terrence joining us as a senior consultant from Improving Houston. Terrence is a senior consultant. He's been with Improving since September 2020. He has about 15 years of web mobile development experience in Node and .NET, helped several organizations of various sizes and capabilities modernize and maintain their applications and tech stack. He is passionate about developer productivity, automation, and cohesive collaboration. And then we also have Mark. Mark is joining us from the Minnesota enterprise. He is a principal engineer with Improving for 4 years, experienced in distributed systems, including microservice, cloud native, and event-driven architectures. He has helped several organizations of various sizes and capabilities modernize their tech stacks. He understands the importance of modeling as one of the main drivers of effective modernization efforts, and he is passionate about developer productivity, automation, and cohesive collaboration as well. So thank you and welcome to the roundtable discussion. We can dispense with the roundtable participant slide and just show their faces. So looking at getting this application modernization discussion going, why modernize? I'm going to put it out to the roundtable participants. Why do we want to modernize?
So as technology rapidly evolves, maybe I will start, right? Like a business under increasing pressure to adapt and transform the legacy application. And today we will explore the details of application modernization and its importance in today's business world and the transformative impact it can have on organizations. As we discussed in our previous talks, applications don't become outdated overnight. It's a gradual process. So at some point in time, any modern application become legacy system. Usually it happens when the systems face some common challenges. Traditional applications, often monolithic in nature, were built to cater very specific functionalities or services. And these systems are challenging and expensive to maintain or upgrade, as vendors no longer support them. Additionally, they're incompatible with newer hardware or software, making it challenging to integrate them with other systems. Legacy systems may have vulnerabilities and lack the necessary security measures to protect against modern threats. Limited performance and functionality, scalability and resilience issues, lack to use of automations, high maintenance costs. Modern application is one that embraces contemporary principles and technologies to meet the evolving need of users and businesses. So what make application modern actually? A modern application is built using advanced technologies, architectures, methodologies, like modern programming languages like Scala, Haskell, Clojure, modern distributed NoSQL databases like Cassandra, Scala, Dynamo, use containerization and microservices, even serverless technology. Modern applications are known for their flexibility, scalability, resiliency. That's why it's very important to talk about this, about modernizing your application. And business must embrace change and modernize their application to save money, ensure security, as we discussed, prepare for new business opportunity, remain competitive, and most importantly, survive. However, the journey of application modernization isn't one size fits all, and it varies depending on unique business goals, organizational challenges, and the current state of legacy systems. Fortunately, there are multiple approaches to modernization, which we will be talking today about. And I believe Michael would provide us more on, for example, how to practices of application modernization serve the business requirements of maintaining an audit history and attestation.
Yeah, I'd like to add to that an application can be a competitive advantage if you stay on top of things. If you let it fall behind, then it can become a liability and a cost center. So I think application modernization really gives us that strategic edge and prevents us from falling into that pit of just maintaining costly software.
Okay, I can add my 2 cents worth.
Yeah.
So all of that's great. I just wanted to summarize. Usually it comes down to money. An application isn't replaced if it's making money, stops making money, it fails to process its work, or it's costing too much money to execute what it's supposed to do, then that becomes sort of the driver of when we're going to replace it. And hopefully with better technology that has higher scalability rate, resiliency, etc. So usually it comes down to money.
One of the items Marina touched on, I'll probably pick on you, Reed, for this one, was around scale. Looking at modern applications and scaling up from sub 1,000 transactions per second, and then also on the flip side, scaling back down. Any thoughts on how to scale and what scale looks like within applications?
Yeah, we call that elastic scalability in the reactive architecture world. I talked a little bit about this in terms of partitioning workload, but that's the basic thing. You want to be able to scale your system up when there's more load, and then scale it back down when there's less load. And of course, you're scaling the cost down as well. So that's a basic technique. We have software that we recommend there and can build around allow you to have a cluster of machines that can start out very small and grow very big. And it works exceptionally well. So yeah, that's the basic thing for scalability.
Any of our other panelists?
Can I add to that one?
I was going to ask for more contributions, so go ahead, Mark.
Yay. So the two concepts I like to keep in mind when it comes to scaling is the concept of over provisioning and under provisioning, which is kind of another way to say what Reed said. But it's important to pin these concepts because they're actually pretty hard to detect when you're over provisioned or under provisioned. Because, for example, let's say that we expect that we're going to need, I don't know, 100 gigabytes of memory at noon. Well, we may provision 100 gigabytes of memory for our application. But from 8 a.m. to 11 a.m., we only need 1 gigabyte of memory. So if we provision our application for 100 gigabytes, we are over provisioned from 8 a.m. to 11 a.m. So it's important not only to measure when it comes to figuring out if you're over provisioned or under provision is to measure your live system performance, not just what you expect at peak or low downtimes.
Another thought on that. So one way to do that automatically, so that you're not having to do provision manually, is to use some of the auto scaling features and to tie it to the workload. In other words, the amount of work that is yet to be done is probably based on a queue size. And don't base it on CPU or memory. It's always tied back to the actual work that has to be done.
Yeah, absolutely. Absolutely.
And you brought up downtime. So one of the topics that's been discussed this month is how do you migrate an application with no downtime? Gonna open that up. I'm not throwing that one at anybody. So looking for.
Well, I've had to do that in a couple different instances. You'd either porting languages or adding in different features. If you work it in slowly, you can actually start incrementing it in without the user knowing, but it does take a little bit of time to do it that way. But you will have the ability to do it just very slowly but surely. If you wanted to drop it in all at once, they'll notice, and that's going to be a lot different issues. So you could either go phased release or you can go big bang. If you go big bang, that might be what you're intending, but it can be done.
So I would say that the solution there is a roll forward upgrade across a cluster. So if the cluster means you've got multiple copies of the same software running, you can take one of those out without disrupting customer service. And the way you do it is you roll a new version in, and then you roll an old version out, and you just keep rolling that through the cluster until everything's on the new version. What this means, however, is that you've got to pay really close attention that the new version is contract compatible. The APIs and whatnot are consistent and backwards compatible with the old version, so that if other microservices are using that, they are not hampered or cause an issue because of the new version.
Yeah, knowing that you're going to be doing this and making that a deliberate part of your development work cycle is really important. This is one of those ideas that you need to shift left. You need to have that be part of your architectural planning. You need to have that be part of your testing, so that you have confidence that when it is time to go live, you can go live without downtime.
Here. I'm for that.
Talking about deploying and how that looks, does deploying more often increase the risk of failure?
So I've had to face this dilemma before. And when you are facing this dilemma, it seems insane to want to deploy more often because deploying is oftentimes a lot of work. But what you find is when you actually do accomplish this is that you actually lower your risk. The reason why you lower your risk is because you're deploying fewer changes at a time. So it's fewer changes that can break. But there is a cost to that, which is in order to achieve this, you need automation. Automation is your path to salvation on this.
Any other thoughts on automation from the team?
Well, you can
Yes.
even go a little further with it. You can actually use automation to run your what you would normally do underneath your QA side of things. You would normally do that. You could have the QA actually write your test and then run that test every time, as opposed to your QA manually testing and following the sheet every single time. The computer itself can do it. There's no reason for someone to actually do that. They can plan it and then it will work the same way every time. It gives you a more consistent result for finding bugs. It helps you know when a lot of things are broken without having to go and remember every step all the time. Because as humans, we do forget things, but if you wrote it down in code, it'll run it no matter what.
And talking about automation and testing or automation of processes, looking at the area of testing, more on the flip side, how do you recover the cost of manual testing if you're not automating it?
Well, that's the thing. So you're paying a bit of cost when you're actually writing the automated test. That is true because you do have to pay the person doing it. But you don't have to pay the person for that extra 5 minutes every time. So let's suppose you have one function you wanted to test and you're like, oh, it only takes 5 minutes. Well, if it takes you an hour to write the test and automate it, then eventually the 13th time you've paid more for that than the 12 times it took to run it, than it took to write it and automate it every time. That's just in man hours. If you were to actually extrapolate that out to the actual cost of where it is on the cloud or in your repository, that can factor even more cost to it as well.
I'll throw a comment here about test-driven design. I think the right time to do tests is right at the beginning when you're writing the code. It's like, how do you know your code works? Because you tested it. Those tests that you write at that point then become regression tests, and they're executed on every change. In large systems, complex software, something you change way over on the right side may affect something on the left side. You won't find out if you don't have tests on that left side. So building a big, huge stock of fast running, quick tests to make sure the functionality is correct is essential. So I'm a big advocate of TDD.
Any other thoughts from the team? Okay, we'll move on. Oh, Terrence got thoughts.
Testing has saved a lot of time and effort for me as well over the years. You're gonna forget things. You might as well just put it down one time when you're writing the test, have it verify. Like Reed said, TDD is very good. I also use BDD if I have to show the documentation to the client. That way they can have an understanding of it since it's written in business language. You can do both as well, depending on what your audience is. But the idea of testing is very, very helpful for maintaining a system.
Perfect. How do platform engineering practices help to control costs when thinking of modern applications or modernizing your applications?
Yeah, so we have touched quite a few points, and all leads to platform engineering and properly implemented platform engineering and platform engineering practices like DevOps practices, SRE practices will help a lot, right? With the cost, somebody mentioned before, right sizing the resources, for example, right? Cloud cost management tools identify underutilized resources and suggest cost-saving measures, ensures application can use only resources they need, right? For example, so this will help a lot. For example, load testing and benchmarking, regular load testing and performance benchmarking help identify bottleneck, optimize applications for better performance, which can lead to cost saving and reducing the need for additional resources. Definitely, infrastructure as a code. Automation enables provisioning and resource management, preventing over provisioning and providing cost transparency. It doesn't matter if it actually will be on the cloud or in your existing hybrid infrastructure. Definitely, automating repetitive tasks. You should automate repetitive tasks. Automation will help here a lot. By incorporating these platform engineering practices, organization can systematically identify and eliminate unnecessary expenses. So I would rather to propose to go over platform engineering best practices and try to implement them. Yeah.
Any other thoughts from the team? Mark?
So Marina, one of the things I liked about what you said was infrastructure as code. And I like that. I like infrastructure as code a lot. And the reason why is because I'm being persecuted by an integer. Yeah, integer is the number 7 plus or minus 2. That's about the number of things that I can remember in my short-term memory. And same thing with pretty much all adults. And the thing is that the reason why that's a problem for me is that our architectures have way more than 7 things in them. I was giving a presentation the other day to my team, and I had zoomed in on an architecture diagram where there were way more than 7 things, very zoomed in, and then I zoomed out. The only way to be able to remember or be able to manage this at all is with infrastructure as code. It is completely untenable to try and manage large architectures without it. Because imagine like if you had a disaster and you had to fail over. How is your team even going to remember what all the things are they need to stand up?
Yeah, also I can add to platform engineering containerization. How I can forget main thing, right? Services is everything fast. So container orchestration platforms like Kubernetes, you can utilize just vanilla Kubernetes, or if you are hosting on cloud, EKS, AKS, GKE, any flavor of Kubernetes allow for dynamic scaling of application based on demand, ensuring that resources are used only when necessary and thus reducing costs. So microservices and containerization is also a good option. Serverless, maybe. Here's a lot of advances as well, but based on your definitely workload and needs.
Here's the lesson I learned. Infrastructure as code is great, but it's code. And so TDD applies. You need to test it, especially things like failover. Right? How do you know your failover is going to work? You hardly ever need it. You may never need it in the life of the product. But if you've got a plan to do failover and you don't test it, it doesn't work. Because I can guarantee you, if you haven't tested it, it'll fail. So, word from some lessons learned a long time ago.
Looking at what other approaches do you recommend, thinking of cost savings, recommend for saving engineering costs?
I can speak to that a little bit. So if you use a non-blocking asynchronous infrastructure for your communications, you're going to keep your CPUs busy. Right? Blocking a CPU is a really bad thing, and I mean blocking a thread, an operating system thread here, That means the operating system is holding a bunch of memory, a bunch of registers, possibly even a VM table. You can get into a thrashing scenario. If you have enough threads, you're going to cause that operating system to do more task switching work than actual application work. And the value of the CPU is going to go down. So you need to use application infrastructure that makes very, very good use of the CPU. We have a use case where one of our clients went from 200 servers to 8. And that's how you save cost, is the operational cost. Might cost slightly more to build it, but that's the one-time cost. The everyday cost, is the long pole on the cost. So if you can reduce the number of servers or networks or memory or whatever, then that's where the cost savings come.
Any other thoughts from the table?
Yeah, I would like to address some of the development costs as well. It is a one-time cost, but there are some strategies that you can employ in order to make sure that your development process is as efficient as possible. And one of those is understanding what it is you're building upfront. So it seems kind of obvious, but there are modeling techniques that we can use in order to make sure that we have a common understanding. That we get all the stakeholders in a room, that they understand that when they say the same word, they actually mean the same thing, and to write those definitions down, to document those interactions, and that way, when you go off and you build it, you know that you're building the right thing, and there's not going to be a costly rewrite after that.
Any other thoughts? We're talking about kind of going down the modeling world, domain-driven design, and those other types of concepts. Reed, you come off mute. What are your thoughts on that side of it?
Mike was probably a better person to answer that, but I'll take a shot at it. So I've established something called Riddle, which is a DDD-based language that you can use to validate your design and generate documentation, etc. Getting everybody on the same page as you're going through the changes that inherently happen is very, very important. One of the biggest costs is building this excellent application that works so well, except it's the wrong application. Right? It's like that happens, and we need to try and keep it on topic, on target for what the customer wants. So Riddle's one helper there, but agile processes help as well. Things change, and they change in real time. Your competitors change, the law can change. Lots of things can happen to a project as it's moving along, and being flexible and agile enough to deal with that is super important. Keeping the costs down. There's also, newer, better ways come up all the time. And if your system architecture is such that it can take advantage of those, in other words, it's not brittle and you have to do it just this one way and it's going to stay that way for the whole project, then you can also take advantage of some cost savings of new tech that comes along. So just a few extra thoughts.
Michael, I know you led the talk earlier this month around modeling. Do you want to share your thoughts?
Yeah. So the idea of getting all the stakeholders in the room to share their understanding, I think that's the first place where you see some advantage. But then also, as Reed was mentioning, then having a common language and even some common tools that you can use to document that model, that will really help with the execution. So tools like Riddle and other modeling tools, it cannot be understated, or cannot be overstated. We shouldn't understate anyway. The importance of making sure that we have machine validation, that when we write something, it means something. The ability for us to take a model and then generate a test and verify that model is correct, to be able to point that model at an API and verify that API conforms to the specifications that we've written. That is really powerful stuff. The biggest cost that I've found is when you get two things together and they don't integrate. We thought that we built this web UI to talk to this API, but as a matter of fact, we spelled something different. We used a different case. We put an object into a value into a different object. If we can catch these things earlier with these automated tools, with this machine-assisted modeling, then we can go much faster.
And maybe anybody have any thoughts in thinking about modeling, just around the overall approach of what that modeling looks like, and the steps you would take in understanding that, and some of the maybe some workshops that we might run through. Any additional kind of concepts or thoughts anyone can share?
Yeah.
I can't.
Yeah.
Go ahead, Michael.
Well, I wanted to start with one of one of the first ones that you can do is to have some kind of an event storming workshop where this is for stakeholders. This is not primarily for the technologists. It's for the stakeholders to understand their business process. So that's a business process modeling technique. It has some really nice side effects that the output of that is a series of events, domain events, things that happen in your domain, and then those map very nicely onto distributed systems and take advantages of some patterns that we can talk about. But yeah, start with I would say start with event storming. Reed, you want to add to that?
Yeah, so I've got the perfect corollary to that. Don't start with database schema. Okay, the database schema is just an artifact of how you're going to store the data, and it doesn't represent the logical concept that needs to be exposed. So this is why I love DDD, domain-driven design. So when you're going to take a domain, you're going to pull it apart, you're going to find bounded context, find entities, assemble the entities until you find an aggregate entity. These are all DDD terms, and I would express any design for any system that way, any system of a decent size. There's places where DDD is not appropriate, but it's usually embedded or small type things. And as Michael was saying about event storming, there's also an AI tie-in here. Events are actually facts, right? They are something that happened. They're not anything to do with intention or whatnot. There's stuff that happened, and consequently, they're a great source for driving into an AI model, even in real time, to train that model for its next generation, next revision. So, yeah, total use of event sourcing. It's great methodology.
I have something to add to the statement where you said, don't start with your database schema. I love that. Another thing is, don't start with your microservices. Monolith to microservice is a very common modernization pattern.
Yep.
And the advice that you'll see out there in the wild when it comes to microservices is that every microservice should do one thing. Well, that's great, and that's true. But how do you decide what that one thing is? That's where domain-driven design comes in. I think, in my personal opinion, that is the gold standard for how you decide how to break up your microservices.
Yeah, and even a bounded context. So when you design a bounded context, you're creating a ubiquitous language to describe some set of features and the high level design of how it's implemented. But even there, when you go to do the implementation, you could have, well, the read side, the write side from a CQRS, the projector. These could all become microservices too, but don't start assuming that they are.
Yeah.
Right.
Yeah.
Just one microservice for a bounded context is enough. If you demonstrate a need to break it apart, fine, but don't do it until there's actually a need, a performance or scalability need. So yeah, I do this thing that I call locally distributed. So I'm going to design something that is locally distributed. Sounds like an oxymoron, right? How can you be local and distributed? Well, what it means is build your software and structure it in such a way that it could be distributed. So we're going to start with a monolith. We're going to start with one big thing, And then when we demonstrate a need to break it apart, breaking it apart should be really easy because we've put all the things in the right category. We've separated domain code from infrastructure code using ports and adapters or hexagonal architecture. And by doing that, you sort of start a project off in the right structure that you assume it's going to grow and need to be scaled out. And doing so becomes easy. You just, oh, I'll just take this little bit of code, put it over there, and done. So that's all.
Yeah, that's a pattern that I've often heard called the modular monolith.
That's the word I'm looking for. Yes.
Yeah, much much better to build your monolith as composed of modules. Not only does it help you to decompose those in the future into microservices, but also that supports testing. If you have a modular monolith, then you can isolate a module and you can write unit tests. Even they're called integration tests a lot of times, but tests that test a module all the way to the database and all the way from the message or the API. I would say if you're talking modular monolith, save that word integration for now when you're integrating two modules together. Then you can do some really powerful testing there. But yeah, architecting in terms of modules, that really that really helps you to to get to that place where you can build the modern the modern platform, the modern architecture, and the modern workflow. You can have that that whole CI/CD supports built into the way that you actually construct this system.
Right.
Yeah, that's what I meant to say.
Terrence, I saw
What
you come
Michael
off mute
said.
there for a second. Any thoughts from you?
Yeah, so even when you had talked earlier about application up porting over and upgrading, yeah, usually I aim to go for the modernization. What was it, the modular? I forgot the word.
Modular monolith.
Modular monolith. So usually
Yes.
the first step in making sure everything that they understand everything that's going on in the application before you start trying to separate out and things into microservices or not. You might not necessarily want to take that step at that time. So if you have it separated out, you're prepared for the future, but you still have everything organized for the current.
Maybe a step in a different direction with this question. Does it always make sense to modernize an application? Is there an instance where we would not want to modernize an application, and what would that look like? I'm gonna pick on somebody soon. There we go. Reed's got thoughts.
So was that me coming
Yeah,
off mute?
I'm picking on
okay.
you.
So sort of the opposite of what I said about money at the beginning. Why would you want to? Well, if there's no reason, no business reason to do it. In other words, the thing is working fine, but somebody wants to do it. Hey, let's rewrite it in assembler language. Like, no, that's not a good reason. So there needs to be some sort of business-oriented reason to do it, where you're going to actually make an improvement in hopefully sales or lower costs, something along those lines. That's the first thing I thought of. So maybe more will come.
Michael's got thoughts?
Yeah, Terrence told me something about resume-driven development. Terrence, what was that?
Oh yeah, if you start planning for resume-driven development, you're going to need that resume a lot sooner. Like in general, if something is so, there are a lot of aspects where, so I've worked previously in a couple different fields, and as far as in IT development, one of which is where they have a high need for keeping amortized assets, so they try to run something as long as possible. If you're not putting something, if you're using something on, say, for example, a computer from the 80s and you're never changing it, there's no need to try and move it from basic to C# or something. It's going to be where it is. That's the tool. That's what it's designed to use for. It doesn't have to be that far up. So you have to assess the situation in whole as to what you're actually using it for. So if you think of the program as a tool, as opposed to just, oh, we want the latest and greatest, like sometimes a hammer just needs to be a hammer. Just keep it as a hammer. It's fine. You don't need to have it as like this new chainsaw or something like that. That makes no sense. Why would you change it?
Yeah, as you're making those decisions, I would evaluate each of the different business functions that your software supports. Is this part of your core domain? Is this going to give you competitive advantage? If so, then the argument for modernizing that part of the system is much stronger. However, is this something that you just need to do because it's a service that is required in order for you to deliver your core domain? Can you just buy that instead of building that yourself? Can you upgrade from the Access database that that your nephew wrote and then buy an off-the-shelf package to replace that? Then that is a really strong argument there. So so yeah, be strategic about what you choose to modernize.
I think the collective commentary here is really that business case driven decision to move an application through that world. There's got to be a reason to go down that road and to spend that money and invest that capital. To modernize an application, what are you getting out of it? So it's all coming back down to that business case kind of thought process. Are there any other benefits to think of when we think of modernizing our application landscape?
It'd be more than one.
No other benefits we want to highlight?
Well, I know that there are a couple different things you can do. Whenever you modernize, you can kind of use a bunch of different new tools and make sure that you're slowly but surely keeping up with technology, especially if something's public facing. You do want to do that with regards to not just your cloud side or your program side, but just even something as simple as how it looks. Styles change. People might want to look at something that doesn't look like it was built in 1998 in 2021 or whatever year you go in the future. You might have to upgrade with the times. So just even from a visual aspect, you want to keep up with certain things just so that it still has the appeal and intuitiveness of what we learn going forward.
Yeah, to that point, there's also sort of technical grades. I guess sort of an absurd example to make the point, but like if your system is based on X25 protocol, it kind of lost. You should upgrade to TCP/IP. There's different things like that you can do, and you can it can turn into more customers just because you have the right user interface, right? I mean, a more recent thing is, do you need a web app, or do you need a mobile app, or do you need both? Far more work is done on mobile apps these days than not. So it doesn't matter what it is. There's all kinds of different technologies, but that can be a driver. And a benefit is that you might actually get 10x more customers just because you made it available through a technological channel that wasn't previously available.
Yeah, I was just reminded that I should give a shout out to accessibility. Accessibility is one of those things where it might not change how your underlying system works, but it's one of those visual user experience type drivers that you might want to pursue as part of your modernization, even if there are aren't other drivers. Words.
Mm-hmm. Yeah, and there are other things as well that we're starting to see come to fruition that you could really take advantage of if you decide to modernize. So the onset of artificial intelligence, machine learning, the amount of tools that are available to us now in that space. Those are a lot easier to take advantage of if you've got some some of the modern practices behind you. So as Reed was saying, if you've got that history of events, then you can use that history to train those machine learning models. And then you can find some competitive advantages in places that maybe you didn't even think to look. So those things become available to you as you decide to modernize. Take that investment.
That's a good point, Michael. And in fact, some of those things, modernizing is a prerequisite. Like
What do you
try
mean by
and,
that?
well, so for example, if you want to get into machine learning, you need to be able to have your data, prepare your data in such a way that your machine learning model can use it. And your legacy system probably is not set up for that. And so how are you going to move that data to where it needs to be so you can modify the data and load it into your training program?
Even
I
within
think
AI, there's changes coming. They're happening now. So Python has long been the language of AI, but it's horrendously slow. Often what happens is people, the data scientist writes it in Python, and then somebody gets to translate it to C++ and actually productionize it. There's a new language called Mojo by a company called Modular that is basically making a Python compatible language that is compiled by the same backend that Swift or Clang uses, the LLVM backend. And it turns out that that's around 85 to 100,000 times faster than Python. So, even within a space, you might just want to okay, we had Python, so it's still, we can convert it to Mojo. The code is still viable. It just runs it somewhere between 20 and 100,000 times faster. Make the change. It's a simple change, right?
Mhm.
So some technological advantages are like that. They're just sort of how do you compile it or how do you use it sort of change. And you don't have to change the whole design or architecture of the system. It's compatible, backwards compatible. So I look for those kind of things. I haven't done that one myself, but I'm really looking forward to finding a project that like we need our Python to go faster. Okay, I have a solution for that. And yeah, it'd be a fun project to work on.
And so maybe taking us down a bit of a different track, another question. When we're thinking of application modernization and building that business case out, what are the roles you would expect to see on a team like that, as far as looking at an application, looking at a business function, and any applications that are in that, and understanding how you would, if we should modernize, if we shouldn't, who are the players in that scenario?
I think you need to start with a small team to capture the requirements of the application that's going to be requested. You sort of need to refresh the idea of what does this thing do and why. And so, yeah, capturing the DDD design of the system with the business analyst and maybe a software architect, and just start with a few people and grow from there. Because getting that clear idea of what that application is about, what it's trying to do, what its objectives are, that's going to make the new thing that much better and that much more clear. Or it also gives you a list of all the things that you might want to reconsider. Maybe this functionality is no longer relevant, or that's the old way we used to do things. We want to do it a new way, etc. So it gives you a chance at the very beginning to reassess the functionality of the application, and to be clear on what it is you want to build. Super important.
Yeah, I love that idea of starting small. In fact, I would even say, and keep it small. As you grow, keep it small. How does that work? Organize your software teams around business units, around the capabilities that your business delivers to your customers, as opposed to organizing your software team in terms of their roles. So you've got the architecture team, you've got the DBAs, you've got the front end developers and the middle tier developers. If instead you're focused around the business unit, then one, you keep your team small, and communication is a lot faster, and they can be more agile. But two, you are also now all laser focused on delivering one unit of value to your end customer. You don't have somebody who is laser focused on making the best REST endpoint. It's like that's not the goal. The goal is delivering value to the customer. So yeah, as you modernize your software, also modernize your teams, organize them around those deliverable business units.
And I think we've again talked around this one concept, but thinking of cloud adoption and going cloud native and tapping into those technologies, Marina, what are your thoughts when you're thinking of application modernization and what the benefits of the cloud and why you'd make that consideration of tapping into that?
Yeah, I just like to, that's a great question. I'd like to add a little bit to why and what else we can do during application modernization. There's a lot of consideration, right, should be taken care of. Also, it's opportunity to re-architect and design your data, right? And how you will use the data, what databases you will use, how you will structure everything. And most probably you will be, by doing even this, you will be ready to utilize those AI/ML capabilities in the future. Who knows, maybe like in 1-2 years, application which you don't have on the top AI/ML level of processing and additional insights will be considered as a legacy, right? We're evolving very fast. So it's very important to think about also additional benefits like which will come along with the application modernization. You can add this data architecture, you can modify, you can also advance your security compliance to be up the level, yeah, to top the level. And about cloud migration, personally, I think it's a huge advantage if company can be onboarded with a cloud platforms. What it does, actually, it could reduce CapEx and OpEx, like capital expenditure and operational expenditure. For capital, definitely it's no upfront hardware costs, right? You won't be maintaining any servers. It will help us a lot. You could pay as you go on based on pay-as-you-go model. It will help save cost as well. You need to be very careful, definitely with the cloud environments, because only one push of the button could cost you thousands of dollars through the day, through a few of the hours. So you need to be very cautious, like what you're doing over there. That's why no manual intervention. Please go and automate as much as you can, schedule as much as you can, use advanced monitoring. Actually, cloud could provide you with very advanced, detailed monitoring tools. Also, billing and cost management service, they have also a very detailed fine grind billing reports, so you can maintain and you can see. But definitely, it will comes with a organizational change, right? People culture, additional trainings, how to do this practice, how to onboard with the cloud, how to, like, there should be roadmap, properly defined set of steps. We can actually help you if you are struggling with any of these items. We can help you, we can guide you how to make everything work smooth and very well. So that's what I can say about cloud migration. Not every company would need to migrate. Maybe some company still could be redesigned on premise or hybrid, like whatever infrastructure they have underneath. It could be enhanced and optimized. It's not necessary to go to the cloud, but cloud can bring a lot of benefits if that specific workload would need it, like, for example, to utilize CDN or any things like based on industry needs, right, and that workload needs. So it could bring a lot of benefits.
Well, thank you very much, Marina, and to all of the panelists for our session today. We're coming close to time. I'm just going to start wrapping up, but do want to just say how much I appreciate everybody taking the time to be here today. And as far as keeping in touch, we've got this one here, but I will hand it over to Emily to help wrap this up.
Hello, thank you so much. This was definitely very informative, even for somebody like me who may not be the most technical person ever. So I really want to thank our panelists for coming in and taking the time today to share their expertise and their knowledge. As Kenneth noted, we do have everyone's improving email posted. And then I would encourage you, if you want to keep the conversation going, reach out to any of the panelists we have here today. Follow us on social media. Most of them have LinkedIn and personalized websites if you want to reach out. Of course, I want to encourage everybody who joined again today to come join us again. We provide these virtual lunch and learns weekly, and all the information is posted at improving.com. Next month, we'll be kicking off our cloud computing information, and Daniel Brown will be our first host. All the information, again, can be found at improving.com. Kenneth and panelists, thank you for your time and your expertise in sharing all of your knowledge with us. And everybody who joined, thank you for giving us your time. I hope you have a fantastic rest of your day and rest of your May.
If you want to
Thanks
reach
so
out to me, my name and that is spelled